Hello everyone. So yes, I'm Isabel, and yes, today we're going to talk about Kubernetes and microservices and modern application architecture mostly. And well, I hope you at least learn something and understand also a bit more about our platform and our product. So what we will talk about? Well, we'll talk about why do we need a bit of API security, what's going on right now, why Kubernetes and the new architecture, and what is it changing in terms of approaching security. Our probably key value proposition, I would say, for TitoCrunch, which is using a positive security model. And we'll talk about what that means and what that means to do that at the traffic level and to do that at the application level. We'll try to probably clear out some confusion that I see very often with our customers in terms of what do we have to do and where in the different layers of the architecture. Okay. First of all, right, this is something we say every time we do a presentation. Yeah, as you probably heard, there's a lot of problems out there, and if you haven't heard about them or you don't know yet, please go to apisecurity.io, which is the site that we curate and Dmitry Sotnikov takes so good care of, and go and see what happens to others, basically, right? And those are just the problems that happens to people and are public ones. But if you look at all those problems and what happened to Starbucks and T-Mobile and others, in the end, and I was discussing this with a potential customer yesterday, I see so say we're not learning, Isabel, aren't we? It's like not really, right? So for the past 20 years, everybody in security is saying, please don't trust anything, don't trust anything. Everything that comes your way, you have to validate wherever it comes from. Don't just consume data directly, check it, right? So input validation is still the number one problem at the root of many different issues, and we'll talk a bit more about this. Of course, rate limiting, making sure you don't let everything open, and ensuring that anyone can do any type of calls, whoever they are and however they're calling your API and how often they are calling your API. And it's also a critical aspect to protecting yourself from many authentication issues, right? And one thing which is very specific to APIs, and we're going to come back to this in a second, is everything related to data and exception leakage. This is one thing that APIs do, is manipulate data. And number one issue, as probably you know from if you've been to previous webinars with us, and if you're looking at the OWASP top 10, the number one problem on the list is this, data access authorization flaw. So not only protecting operations and ensuring people cannot call a specific operation, but once they have access to the operation, making sure they cannot access and retrieve the resources and data that they actually don't have access to, right? So this is the core set of problems that we're facing, and we're facing them everywhere, and it's really impacting everyone at very high levels, from the smallest to the largest companies, right? Now, why is this happening, right? And really, if you look at, and this is where the Kubernetes link comes into the picture, right? Is how we've changed the architecture of our applications from basically having everything on the server side and exposing just the information to display information like HTML, for example, back to our client apps, to a world where we basically are exposing directly data and processes all the way back into our application. And it's the role of the application to actually take that data and message it and then display it in any way or shape or form. So if we just get direct access to information and data as opposed to, and require data as opposed to just getting access to the presentation layer, I would say, of that application, right? And using applications such as microservices-based architecture is only making this problem worse in a sense, because rather than having 3, 4, 5, 10 APIs, now we have hundreds and thousands of API. Like most of the customers we talk to, they have hundreds. and they're going towards the 1,000 of APIs in terms of having to, in terms of the applications that they're building. It's basically an API for absolutely everything, and micro APIs for a lot of things. So there's a lot of, little islands like this of data that we have to protect, which is why, Gartner and others saying this is going to become really the largest surface attack, more than the UI, in 2021. Well, we are in 2021. So what, and that's exactly what is happening, at least in every customer that we were talking to. Now, one of the key things I'm sure you understand that Kubernetes is doing, right, is has completely revolutionized and basically microservices-based architectures, the way traditional security had to be done, right? We used to be able to build those walls around our company and protect basically the data. But really what we're doing now is every time we open an API, every time we open and create a new microservices, we're actually creating avenues into that data. That's what really this architecture is actually doing, right? And what makes even the problem worse, it is, I think if I look back at customers, what has changed a lot is we've given to the development teams this really means to be extremely fast, extremely agile, everything is automated, right? Most of the people we work with, they have in place, I'm a developer, I write my code, I'll just push that code into a repository and some magic happens and it's getting automatically tested, it's getting automatically deployed. And at the end of that pipeline, I have a new version, and I can do this like, hundreds times a day, right? And create new versions and incremental changes super fast, automatically tested, etc. That's the flexibility, agility, productivity we have given to development. But as we were doing that, basically security is a bit late to the party in here, if you allow me the expression. And I think it's late to the party in two places. It's late to the party because they don't have the tools to really for that world, right? And it's also late to the party because they're usually considered very late in that life cycle, right? So when this was it was already problematic before development got all that, agility and speed. It's even worse right now. Discussing this with a customer the other day, where they'll still have to do a lot of manual security reviews, in the sense that the new API is being published and they have like this process that people have to fill, a ticket of some sort that engages the security guys, and it will go and review what is it that you're doing, how is this secured, what is the data you want to expose, we're going to be the consumer, do a threat model, etc., etc. And all of that is manual. So as the number of APIs increases, and basically they have to make a choice. They have to choose which are the most critical APIs that they are going to manually review, because basically physically it's impossible for them to scale those reviews across thousands of APIs, right? So it's one of the reasons we're actually talking to them and say how we can automate a lot of that and just keep the very high-end, pen testing basically for them to be a manual task, but not the mundane, repetitive testing tasks that they have to do right now, right? So all of this in Kubernetes is basically, more complicated, and simply for the sheer number of APIs that we are producing and the rhythm at which those APIs are being produced, right? So one of the things that we advocate at 42 Crunch, first of all, is basically to, automate and shift left and look at this as early as possible in the API lifecycle. But also we're, very strong believers of a positive security model. So what is a positive security model? It's basically a model where you define what is expected and reject the rest. And the reason you have a boarding pass here is just because an analogy that we use sometimes with customers on saying, you're going to come to the airport, you're going to come to the plane, we know everything about you, right? We know you're going to onboard on first class, lucky you. Where are you going to have to be? So if you're not in gate B42 and you gate B44, you're going to go through with your flight number, etc. how many bags you have, anything about you, and anything that doesn't match that then will basically reject you, right? And the key thing about a positive security model is really don't care about so if we transpose that into our world, which is a security world, right? Rather than worrying about what is this new attack that's basically coming my way, right? Which typically what you would do, let's say you have an antivirus, and I hope you do, or anti-malware installed in your computer, right? Your antivirus is only as powerful as its database, which lists all the type of viruses that it knows about and all the signatures about those viruses, right? Viruses. If there is a new virus popping up and you don't have that signature in your database, then your antivirus will not find it because it doesn't know about it, right? And that's, the typical security model. We have to describe what it is that you want to reject as opposed to what it is that you want to accept, right? So all our model is based on the fact that we just reject what we don't know about, right? So, and that includes, who can talk to whom, authentication, authorization, and basically, right? So on our recommendation, really, from an approach point of view, is really would be to really describe what is it that is allowed in my architecture, okay? And in a Kubernetes model, you're going to do this at 2 levels. So this is very important. What we're focusing here, basically, by the way, is on application level security. Within the Kubernetes world, there's a lot, of other aspects that you need to care about, such as the, security at the infrastructure itself, of course. What are the images that you're going to use? Are they vulnerability free? All the container security type solutions, for example. So that's kind of a different domain a bit, but it's also part of the overall Kubernetes security. But what we're focusing here in this chat is more about the application level security, right? And here is the opportunity to basically clarify something that I see as a lot of confusion with customers, right? Is the first thing that you will have to do is to create that positive security model at the network level, right? And this is all about which microservices can talk to which microservices. So the typical architecture, we have clients, we have an entry point in our application, we have multiple microservices. Those could be single microservices called, through an API management gateway, for example, or something like that. Or it could be microservices collaborating together and talking to each other to provide a certain functionality, right? So you have a lot of intercommunications here. Should it be what is called north-south, so coming from the client all the way to the microservice, like top to bottom here in that picture, or what is called east-west, which is the microservices talking among each other, right? So it is really important at that level to make sure you control who has the right to talk to who, right? So for example, no one should be able, like our little hoodie attacker here, to come and talk straight into that microservice, because at this level here, you should have something that says, no, the only people I'm talking to, the one which is right next to me. Anything else, I'm not talking to, right? So that's the first level. This is really about establishing the communication and making sure that you allow microservices to only talk to whoever you have, chosen to do so. And this is really something you want to do as policies. And this is where a service mesh gets into the picture, right? So some of you may have already deployed this. And the idea of a service mesh is really to control by policy, how are all my microservices talking to each other and communicating, right? For example, I want to impose mutual TLS authentication between my proxy A and service A and service B. And the idea of the service mesh is, rather than embedding all that logic, which is what we used to do before service meshes were created, inside the services themselves, and have all those services that control that communication within the overall services. Instead, we're going to have something that basically intercepts all the calls in between microservices and controls how those communication is established. So what is the communication? Who has the right to talk to who and how? So most likely, at least, you want to enforce some mutual TLS authentication here just to make sure that effectively if somebody comes from outside, they actually cannot do that because they won't have that certificate to present, right? And then the service mesh will manage all the certificate management, observability, the making sure you have HA and failover when service A talks to service B. But all of this is at the communication level, right? So a service mesh is not looking at data. It only looks at the communications and whether those communications can actually be established. So that's the first level of policy in a positive security model, because you will have to describe, hey, this is my architecture and this is who has the right to talk to who. One extra point about this would be if you're creating such an architecture, for example, not have your front end layer, which is where you expose your APIs maybe to the outside world, right? Being directly allowed to access your data layer that has access to your database and your information, whatever that is, right? You want some kind of controller layer in the middle, and by definition and policies, you want to make sure that that first front end layer can only talk to the controller, and then the controller can talk to the backend, right, and the data, but not a direct connection from the front end to the backend. That's the type of policies you can establish with such solutions, right? Now, what are we bringing on top of that, and what happens now at the API level, right? So, and that's at the data level. Here, what we are going to establish, in the service mesh is by authentication and authorization, again, at the service level. So service A has the right to talk to service B. And this is the identity that service B is going to expect from service A to say, yep, I allow you to come in, okay? So there's one level of authentication and authorization here at the communication level. But there's another level of authentication authorization at the API level, which is more like a business one, which if you want, which is like Isabel can talk to this application that's Isabel, and Isabel has the right to call the API, whatever, accounts, right? That's completely different. That's totally independent from the way the things are happening behind the scenes and underneath, right? I would have the same authentication authorization if I was not using microservices. That's kind of independent of this architecture, right? So here our recommendation is really about every API needs some kind of authentication. Which one, you have the choice. You may want to do, I'm working with a customer now still using basic auth, but they have coupled that with an API key, for example, or it can be OAuth, or it can be, a mutual TLS. It really depends on the risk and the as we said in many of those webinars, I think, is we need to adapt the security to the risk, right? So depending on the data, depending on where the API is exposed, who's going to consume it, you need some kind of authentication. Be very careful, like if you're feeling yourself in a situation where you say, maybe we want to remove entirely and leave it totally open, think twice, because there are very, very little use cases where you actually would want to do that, right? Unless it's extremely non-sensitive information, an isolated system that nothing else is there. There's all kind of precautions that could be taken in here, right? And then on top of that, you also want to put authorization, right, for the data and functionality, which is two part here, which is, does Isabel have access to account on, post account or only on get account, right? Well, that's one level. And the second one, which is often forgotten or not there because it's much harder to do at a certain level, is how do we enforce that Isabel can only do get account on account 123, but cannot do get account on account 125, right? And this is at the resource level. So if any of you are using here OAuth with resources and scopes, right, where you say, well, I have the scope that I'm allowed to that was granted to me, right, through the when I obtained my token. And with that scope, I have access to operation A, C, and F, right? That's one level. The next level is once I have access to that, which data do I have access? Which is number one, API 1 problem in the OWASP top 10. So it's a key problem, right? Now, how do we enforce all of this at API level within 42 Crunch, right? So we're going to take the approach of defining a contract. So your API as a contract. And when we started this company, we'll look for something that would say, make it very easy for someone to describe, this is my API, that's what it does, this is all the data that can come in, this is data that can come out. Basically being able to express and describe every piece of data flowing in and out through my API. And if you think about it, this is really what defines, what are the allowed interactions with your API. Anything else that doesn't conform to that contract, and that could be, bots calling us, that could be somebody basically trying to play around and see if they can get the API to get it to trigger. We see quite a lot in this API Security IO reports. Basically, the ability to go and do a post instead of a get, or inject data or whatever it is, just to basically force the API into a behavior where it's going to start leaking data, leaking exception, and from there we can pull a thread, as a hacker and get more information. That's exactly what they do. They'll go and play, and try, and depending on the response, they will just make some conclusions on what's going on, right? So anything, injections, pass transversals, mass assignment, and the other way around, very important, right, is what am I going to answer? So it's not only about blocking inbound, which people mostly, think about, and it's all this validation I was talking at the beginning. It's also making sure that you don't leak information coming out, okay? Now, what is a good contract? Right? We define this as, okay, what's a good contract? Well, first of all, we have security in our contract, some kind of definition, basic auth again, API keys, OAuth, right? And then we have defined all the data that this API can actually manipulate. So headers, parameter, payloads, on requests, on the response. That's very important. And then when we look at, we work with customers and we look at the contracts they have written, most of people just don't constrain the data. That's really the key problem here, right? So for every single piece of information, define constraints. That means don't allow, for example, ever growing schemas that because you have defined three properties in there, but if somebody brings in 10, then doesn't matter, nobody is really looking at that, right? We're all gonna let that go in. So it's not constrained at all. Or everything is a string, right? So every parameter, every header, every lot of payload, every property, they're all strings. Well, but they are not all the same strings. They have limits, they have formats, they have patterns. So this is the type of the tools we're going to give you is to help you create a good contract. And once we have a good contract, then we can do a good job at filtering all that. Okay, so this is no different than the advantage. I'm sorry, in architecture like Kubernetes, right, is the scale. So the key point here, what we're going to allow you to do, and I'm going to show you that in a minute in the demo, is to scale the deployment and automate that deployment and automate the security information validation, right? And automate the deployment of the protection for your API, right? And you can do this API per API. So that's also something which is really critical for us in the situation. If you look at this picture, which is, revert back to the one we saw like 10 minutes ago with the service mesh, right? We have our different microservices. What we're going to allow developers to do is basically to deliver to the mesh, right, a secured, a pre-secured, an already secured microservices, right? So we'll have a protection, an individual protection based on OpenAPI for every single microservice, right? So this is very, key in the sense that every service is different. Every piece of data that a microservices flows around is different. So we need to step away from solutions which allow you to really and generic rules. That just doesn't work for APIs, right? It doesn't work because every single API is different and every single microservice is different, okay? So the idea of using our solution, I'm going to show you now how this works, is really to define a contract, harden the contract, right? And then deliver as development, deliver a secured microservices to the mesh, where every single piece of data that flows to that microservice is actually validated, which comes on top of the existing, hopefully, communication level validations that you're doing with the mesh, right? So with the mesh, we protect at the communications level. With our firewall, you protect at the API and at the data level, okay? So I'll just get out of this for a second, and we'll come back to the presentation later to actually show you how this works, okay? So I have an existing Kubernetes cluster deployed. It's running. It happens to run on Azure cloud. It could be KS. It could be any Kubernetes. We're totally agnostic of any of that, right? On that cluster, I have an ingress controller deployed that you can see now on the screen, and nothing else, right? So what I'm going to do now is simply install and deploy an existing an API that I have, for which I have created a Helm chart. So I'm just going to go and install that, right? So we have a Helm chart that installs this. If you came before, you know about our Pixie API that we use in demos now. So we're going to install this in our namespace called live demo, right? So that should take a couple minutes, and we'll just go and wait until this is actually all up and running. And if we go, well, it takes 5 seconds, and I have my Pixie API up and running. It is in my ingress, which has a pre-defined IP address, just a fixed one. So if I call this now, it should give me a token. This is all fine. This is my API. It's all working. I can get information about the user I just created. Let me just create a new one here. So you see this is actually working. Webinar. There you go. Webinar. There you go. Right. So I get a new token. If I just get user information, you will see here that there's a new user, number 45, and it's called webinar. Okay, so I can work with this. Now my API here, it's just protected at we said, communication level, not at data level, right? That means that it has a certain set of behaviors. For example, it's not really, looking very well at the different options that we're sending some bad verbs or some bad data. It reacts differently depending on the data that we're actually, asking for. It is not validating the data formats, so something like, XML here, right? Nor is it, so it's actually answering badly here because the data type is XML instead of JSON. I'll just correct that for after. Okay, and it's also not validating any type of information here. So for example, it has this nice behavior that if you send it some, I have to put a new user here, right? So if I put some kind of data, and then it will answer some exceptions, right? So that's my established API, and that's what I have in here. All right, cool. So now for this API, we have defined its contract, right? So I have this pixie.json definition, which has, as you can see, a really good score. Why is that? Because we have put in there for every single piece of data. I'll just put this on the side so you can read this correctly. For every piece of data we have, so a user needs to be an email with some constraints, a password needs to be a password with some constraints. I have information about also the responses that come back also with some constraints. So every potential response is described, every header is described. That's exactly what we mean by a good contract, okay? So we're going to use that now to protect our API, okay? So let me show you how that works. What I'm going to do is I'm going to do it manually so that you see all the different steps. Then I'll show you that with DevOps as well. Everything I'm going to do now manually, you can actually do automatically and through any type of pipeline or REST API if you want to, okay? So first I'm going to import, sorry, I already have imported this. So this is our API. It's already imported here, sorry. It has the score of 94, which is what we have seen in here. And we have also created the, when we do that, when we import it, it creates the configuration for the firewall. So as I said, there's a very straight line from describing what the API is and the data it transport, and configuring the firewall to protect it, okay? So very simple thing to do. And all we are going to do here is basically to create a token, right? Which uniquely identifies that configuration, that specific API, right? So let me just create that anew, and I'm just going to add webinar demo. Okay, say generate token. Okay, so what is a token? Well, just a UID, right? That uniquely identifies this API. Okay, so I'll just copy that to my clipboard. All right, so what we saw here is we have our Pixie API, which was running. Okay, so that's all fine. Now, what I have also in this, let me just do it this way. Right, what I have also in that cluster is a Kubernetes Injector, right? So what this will do is when this is installed in the cluster, it will automatically inject our firewall inside an existing pod, right? So typically to do exactly what I showed you in the picture earlier, in this picture, where we're going to inject this firewall here in front of our existing Pixie, which is this block, okay? So it will be inside the same pod or the different container. That's what we're going to do right now, is to inject it there. So this is our injector, and the way an injector is working, if you use Istio or those environments, you probably know that, is you use annotations. So you annotate basically your API, which is what we're going to do in a second. And when the controller sees that annotation, then it will say, oh, I know I have to inject this firewall because I've seen that specific annotation. Same thing Istio does on a namespace level. Whenever you deploy a new pod, it will go and inject Envoy on both sides to take control over the communication. It's the exact same principle, okay? So, all right, so what we're going to do is just deploy our firewall. We want to delete it, we want to install it. All right, here we go. All right, so we're going to install the firewall setup first, right? And this is where we're going to put this token that we have generated, right? Which was EDC, etc., etc. Okay, then go back to my UI here, copy that again. And if it goes, right? So what this will do is it will take that token, it will put it in a secret and generate. I'm actually have this in debug mode, so you will see what's going on. There's basically three things it does, right? It creates a config map with the information about the deployment of the firewall. It creates a secret and with that protection token. That's it, pretty much, right? So now we have the components for the firewall to be able to run, right? And in order to inject, what we are going to do is simply say, please now upgrade our existing API, right? And again, I'm doing this in debug mode so you can see what it does. And it's not in this one, it's in this one, okay? And here, this is where the annotations come into the picture, right? So we'll deploy it, but this time we'll just set a value that says we want to inject the firewall, and we also override the port where the API is actually listening, okay? There we go. So this will do some changes. And now if we look at the pods again, all right, so what we will see in the pods now is we have a new pod creating, but this time we have 2 instead of 1, okay? And the one that was there before is going to be replaced, and now we have a new one running, but with 2 containers instead of a single container, okay? So the injection basically has happened. So now if I go back to Postman, right? If everything is, let me go back to the proper setup here and just user 2. So everything is the same. So in terms of, the contract is good and everything is good, I'm still getting my token and everything is fine, right? Now, what is different now, though, is everything that I've tried before, such as doing, for example, the get, okay? Oh, now we don't have the same result. Now we get a response from our firewall saying, no, sorry, can't do that. And it will be the same if I was trying to override, whatever. I put foo in here, it doesn't really matter. And that will be rejected as well, saying this is an unsupported media type, right? So, and of course, if I put back my JSON in here, right, anything related to the format of the data is also going to be, more importantly, is going to be validated. And this is really the key thing, right? Because again, as I was mentioning before, the important part in protecting each of those APIs which are being created in the environment is that every single API is different, and every piece of data it manipulates is different. So here we know about the data. So we know, for example, that this needs to be an email, right? So if I remove this and it's not an email anymore, then I get a different thing that says, go away, request forbidden. And with very little information about who is answering and why this is answering, but we're just rejecting systematically any call that doesn't match the actual, information we are expecting. And this is also true. Remember the, minus 100 here, right? So in this case, what we're going to block, right, is actually, well, again, this is blocked again, right? So we can't do that because this account balance is actually too low and it's not in allowed inbound. But also we will actually block, that's, I'm above the limit here. We'll actually also block the responses, right? So this is really important because it's not only about protecting the data coming in, it's also preventing the data that is not right to actually get out, okay? It's also making sure that, I forgot to show you that, it was working before, sorry. But in this API, through mass assignment, I can make myself an admin, right? I can just say, hey, I want to override this particular property, which is called isAdmin true, okay? So if the contract is defined like this, right? So it says you can only pass, and sorry, not like this. You can only pass the email and the name. You cannot pass anything else, right? So if we're trying again to send this information, then it's going to be blocked. But if I remove the isAdmin true, and if I remove the password, which are okay, then that's, oh, that should be working. Okay. Did I change something else? Right, I don't know why. Probably because I don't have a token. Sorry, let me just get the token. That's why it's not working. Webinar 3. Webinar 3. Here we go. Now we're talking. All right. All right. So now we can update that user. Okay. But if something else is in there, so let me go back is admin or my password, then it's going to be blocked. All right. Now I know all of this because I know the API. Now the thing is, if I go here to our platform, then I will see all those logs popping up, right? And the protection logs, and why all of this is actually being rejected, right? Because we're not allowing any password coming in or coming out. That's why this got rejected, and everything else in here got rejected. Every single piece of data is just validated property per property, basically, right? So that's kind of how the firewall can be automatically injected inside each of your APIs. Okay. Now, could we automate this? Yes, we can. So, for example, I have here and automatically do the same audit that will go and validate my API and making sure it is a good contract that has the right constraints, et cetera, et cetera. Then I can configure the protection to generate that token that we were talking about, the protection token. What I've done here manually, but do it here automatically, right? So everything I've been doing manually here to show you different steps, you can actually do it here automatically, right? That's kind of the idea. All right. So that's kind of what I wanted to show to you today. So in terms of automating all this, actually going back to that, how do we do this? There's basically two steps in protecting an API within Kubernetes with our solution. The first one is to getting to a good contract. How do you do that? I've showed you the solution now in VS Code that does the audit and gives me a report. You could have the same thing in IntelliJ. You could have the same thing in Eclipse. And as for DevOps, we could have exactly the same thing in a Bitbucket, in a Jenkins, or in a Bamboo, or even something like SonarQube or GitHub Actions, right? So you can plug our audit to get to evaluate your contract in GitHub Actions, have code scanning as part of the code scanning contract, giving you a good score. And once you have this API with a good score, then everything comes out of it directly. So we take the API, we generate the configuration, we push it with the injector in front of the API, job done, right? There's no extra policies to write. There's no manual work required in writing those writing policies and maintaining policies. The only thing you have to maintain is a good contract that has all the information about how the API is actually working. Okay. So in summary, really, if there's one message I would like to push here is use a positive security model. It is much more powerful. By definition, it's not something that has been used a lot because traditionally it is something difficult to do to maintain a positive list, right? But thanks to and B, the tools that we're giving you that run both in the IDEs and CI/CD, then we make that possible, right? We make it very easy and possible to actually enforce a positive security model in our solution. But also don't forget to do this at the other level, which is at the communication level using MTLS and communications, okay? And as much as possible, automate everything. Because as one of the key issues in Kubernetes and type of architecture, again, is the number of APIs you will have to deploy. So the less you rely, I would say, on manual steps inside the flow of creating, deploying, securing your APIs, the less you will be open to problems, because this is by definition a repeatable, proven code-based solution where you can actually have something that you can count on and scale to hundreds and thousands of APIs. Okay. So I'll stop it here so I can have 5-10 minutes left to take some questions if we have any. Christine?
Hey there. Yes, we have a couple questions coming in.
Okay.
And yes, the audio was a little spotty. I'm sorry, guys. Cut out a few times, but hope you got a good understanding of everything. There's only a couple. So it wasn't just you, the person that asked. A question here. Is the API Firewall Envoy based?
This is something we're working on. So the API Firewall is a standalone Docker container that you deploy as a sidecar in front of your existing API. We are working on a new form factor that will be that will be based indeed on the filtering in Envoy. So you can directly deploy the same functionality I've shown you now as an extra filtering option on top of an existing Envoy proxy.
All right, next question. If there is a service mesh deployed as well, is the API firewall going to sit in between Envoy and API?
Yes, that's where it's going to sit. It's going to sit right behind basically Envoy is going to do that communication protection that I was talking about. So this is where you're going to enforce all those policies, like can service A talk to service B and how. And once you pass that, then you get into the API level and data level, and this is where we get in, indeed.
Okay, so I have one that has a few questions in it. I'm going to try to piece this one together.
Okay.
Looks like I have to open egress from each pod to 42 Crunch server with requests being authenticated via a token. Do you support a configuration where tokens are retrieved from a secret manager, such as GCP/AWS secrets manager or HashiCorp Vault?
Okay, so let me try to take this in parts. Okay, so in the platform, you're going to generate a token, right, which is used when the firewall starts up to go and fetch its configuration. Okay, that token, you can store it wherever you want. You can put it in the vault if you want. You can put it indeed in secrets manager in AWS. In the sample I've done, it's just a straight on Kubernetes secret. That's really your choice, right? As long as right before basically when you configure the firewall, you actually can retrieve that information, let's say from AWS Secrets Manager, and put it into an environment variable that you pass onto the firewall, right? Once the firewall has retrieved its configuration, then it doesn't need to go and access the platform anymore. It's just when it starts up, because it needs that configuration information. This is a step also you could do at design time. So that's another approach, which is rather than at runtime go and fetch the configuration and dynamically, if you want, you could also have a task in the CI/CD pipeline where you use the same token, you retrieve the configuration, you create your own image that basically has our firewall together with your API config, and you deploy that. And then indeed at runtime, you don't need that protection token at all, right? So there's two modes of working here. It's very open in terms of where and how you store the protection token. I hope that was clear. Otherwise, just come back to me and I'll do a picture.
All right, here's another part to that question. Is the connection to control plain non-blocking mode? How much of latency does the sidecar firewall add? Can I just audit logs into my own tools?
Sure. So there's a lot of stuff in here. Let me just show something here so you can see the times, okay? So first of all, latency. So one of the key things that we really have done in this runtime is working on latency. So you see the times we have in here. So we used to have this in microseconds. We just had to go to 0.00, people getting confused. So this is 400 microseconds or 0.000 milliseconds, right? So the time it takes to do all those validations is extremely low. It's very, very, we have very, very low latency. And we've done this obviously and spent a lot of time to make sure that we don't add more than 1-2 milliseconds to every transaction, because we're going to see everything going through, right? So now this information you see here as the first part of the question. The second part of the question is, can I take this information you see here, for example, in the UI, in my own dashboards, for example, right? So in here, I have the setup done so that the logs of the failed transaction actually are being sent back to the platform. You can also configure that to send it to files or to send it to STD out or any combination of the above, right? So some customers, for example, they take this data, they consume it into their, they push it into, say, CloudWatch, for example, on AWS, and then Splunk consumes that automatically, or Elasticsearch consumes that automatically, and then you can have your own single pane of glass, maybe with other information you get from other tools and other parts of the architecture, like or using Prometheus to put it in the same place as the data you have from your service mesh, for example. So yes, you have access to all the information. You can consume it any way you like. I think that answers the two questions.
All right, so there's no more questions in there. If you have any questions, I'll give you a second to type. Okay, I think that's it for Q&A for the webinar. Thank you guys so much for joining us. We can't wait to see you on the next one. Isabel, do you have anything to say?
No, thank you very much, everyone. I think we have an extra question just now, but
no, it just says thank you, Isabel.
Just thank you. Okay, fantastic. So thank you very much to all of you. Until the next one, which we think you will find exciting, and we're actually going to go back to doing some Kahoot, right, Christine? Because
yes,
we have a competitive bunch here. They want to compete. So
yes, we are. So I have to think of a prize.
Exactly. Well, thank you very much, everyone. Have a great rest of the day or a great evening, and we shall be talking next time.
We'll see you next time. Thanks.
Thank you. Bye-bye.